switch a microcontroller controlled vacuum tube guitar amplifier. So you're probably wondering what it is to begin with. It's essentially just a vacuum tube guitar amplifier. As you're aware, guitar amplifiers typically have a lot of adjustment knobs in the front. We opted to keep it simple, so we only have 5 main controls. We have one control for the gain or overdrive, so you can have very clean sound or a very distorted sound depending on the type of music you're playing. You also have tone controls. There's a knob for the bass, the mid, and the treble. It allows you to control the proportions of the various bands within your signal. So, say for instance you wanted a very a thin sound, you would turn the treble up and you turn the bass down so that you would only have that component. There's also a master volume knob so that you can adjust the volume. So what we've done specifically is that we've implemented a system to essentially allow you to memorize the actual positions of the knobs. As you're aware, if you're performing live, not all your settings may be the same for every song you play, so it's important to, so instead of standing there and fiddling with the knobs between each and every song, you can actually pre-memorize them and recall them at any point in your performance. So essentially, we have provision to store 10 profiles. So each profile consists of the gain and the bass, mid, and treble. So those 4 tone controls, the exact positions will be recorded, and that counts for essentially one profile. We have memory enough for 10. So you're wondering what a vacuum tube is? It's essentially a device that controls the flow of current with voltage. It's quite similar to your modern day MOSFET. So essentially you can control the voltage at one point of the device and it'll control the current flowing through the device. It was largely used before the advent of transistors from, I would say, the 1900s when it was first invented, the early 1900s, to about the 1970s, 1980s. Today, it's been largely superseded by solid-state components simply because they are more efficient and they're less finicky to work with. So the basic overview of a tube is you have a cathode, which is essentially a metal tube or plate that has a heater embedded inside it. So what happens is you pass current through the heater and the plate, the cathode glows red hot. You obviously, by electrical conventions, the cathode is connected to ground. You also have an anode in the device. Obviously, as electrical conventions dictate, you connect that to a positive voltage. And there's also a wire mesh between the anode and the cathode. So the way it works is when the cathode is heated red hot, electrons start to come off the surface of it, and because electrons are negatively charged and you have a positively charged anode, the electrons will actually start heading towards the anode, and the movement of electrons, as you all know, is essentially current flow. So someone came up with the idea that you could actually add the metal screen between the anode and the cathode, and you could actually add a voltage to the grid. And based on the voltage you add, you could actually control the amount of electrons flowing between the cathode and the anode. So it was one of the first devices where you could actually not just switch on and off, but you could switch somewhere in the middle. Alright, so an overview of our amplifier. It consists of 4 main amplification stages. There's a preamp section, there is a tone stack, there is a phase splitter, and a power amplifier. I'll go into more detail about how they work in a moment. It uses 2 6N3P triodes. I'm not sure if I mentioned earlier, but inside vacuum tubes, the type of tube, the number of elements inside the tube dictates what it's called essentially. So if you only had a cathode and an anode, there's only 2 elements, and you might know this as basically a diode, and that's exactly what it behaves as. So if there's 3 elements, as shown earlier, with the grid between the anode and the cathode, then you have what's called a triode. So the triode is used for the preamplification stages and the phase splitter. It uses a 5894 power pentode for the power amplifier. This tube is mainly used for RF amplifiers, but we somewhat repurposed it for our application. We measured the peak power output to be 27 watts, but RMS power is usually typically about half of that, so you should only expect about 13, 14 watts coming out of it, of average power. So the I/O controls, as mentioned previously, there are 5 main control knobs: the gain, the 3-tone controls, and the volume knob. Only the gain and the tone controls are automated. Volume is something you kind of set as you want. It's not quite something you want to really automate, simply because it doesn't really contribute to the sound, it just contributes to the loudness. It accepts a standard 1/4-inch guitar jack, and it can drive an either 4 or 8 ohm speaker. Alright, so this is just a quick block diagram of how the amplifier actually works. So at the beginning you have your guitar, and there are 2 preamps within the preamp section. So the first preamp, what it does is it boosts the voltage from the guitar. We actually put his guitar on an oscilloscope, and we found that the output, just without anything connected, was approximately up to, I believe, 1 volt peak to peak, and down as low as 50 millivolts. But generally, just for average playing, it goes anywhere from 300 millivolts peak to peak to 600 millivolts. So we had to configure the first preamp to have an approximate gain of about 25 or so. So what essentially happens is that circle there represents, I guess you can think of it as a knob on the amplifier. So the first knob is the gain. Essentially what happens is you're controlling how much drive the next stage gets. So the further up you turn, the higher the amplitude will be received in the second preamp, and the more you're overdriving it and thus distorting it. So the preamp drives what's called the tone stack. The tone stack is just a fancy term for a multiple bandpass filter. It allows you to select how much of each frequency component you want within your signal. And after that, it goes into the master volume knob and phase splitter. A lot of people think that you would put the volume knob at the beginning, but what happens though is that as you turn that gain knob higher and higher, the output of the second preamp is, proportionally grows higher and higher. So it wouldn't make sense to limit the volume coming into the first preamp. Because the first and second preamps are simply there for distortion and tone shaping. So it would make sense to, after the tone shaping and after the tone stack, you would control the amplitude being fed into the power amplifier. So the phase splitter is used to generate a 180-degree out of phase signal, because what we're using in the power amplifier is a push-pull class B. Essentially, one device handles the upper half of the signal, and the second device handles the lower half. So in order to have them both pushing and pulling at the same time, you need a 180-degree phase shift signal for one of them. And then you have your power amplifier, and you have a speaker at the end. The power supply takes a standard 115 watt. There's an IEC plug, as you find in your guitar, on the back, and it's fused for, I believe, 2 amps to protect against any short circuits or anything. It uses a toroidal step-up transformer, which has 3 secondary windings. One is a 200 volt winding, one is a 12.6, and one is a 6.3 volt winding. The lower voltage ones are typically used for powering the filament or the heaters of the tube. There's a master power switch and a standby switch. The master power switch essentially allows power to the transformer. The standby switch is to prevent high voltage from being applied right away to the tubes, because it's been found that if you apply high voltage to a tube before it's fully warmed up, what you'll have happen is the electrostatic force will actually strip particles off the cathode, and you'll essentially ruin the tube. So they have to be warmed up. And as another precaution, we also built a relay interlock that's controlled by the microcontroller, and it essentially forces you to wait 30 seconds before anything can receive the high voltage.
10 minutes. So I'm going to be talking about the control system of the amplifier. So what we're using is an Arduino Micro, and essentially this controls the push buttons. It's programmed. It's the main user of the automation of the motorized potentiometers, and also drives the 7-segment display. And so the potentiometers that we use is a motorized dual gang potentiometers. So this means that one potentiometer has one gang motorized potentiometers have two potentiometers. One is to read the analog value, and one is for the actual circuitry. And to drive the 4 motors we have is to use a pair of motor driver ICs. So each chip can drive 2 motors, and each chip has 2 enabled inputs for each motor. And what the program does, what the Arduino does, is to turn on one motor at a time. It also has, the chip also has two H-bridge circuits, and that is used for direction controls, which are all tied up all together and driven by 2 outputs of the Arduino to minimize the Arduino pins used. And we auto-isolate the Arduino with the motor circuitry by using a 4N25, and this is to protect the Arduino from any induced current from the motor. It consists of a main control board and a user interface board. It will look something like this. And we have 3 tactile push buttons, which the up and down button will help us scroll over the 1 to 10 presets, and it'll increment the current value by 1 and decrement the value by 1. And the set button is to load the current preset that we've chosen, and when we press the up and down button, it should be displayed on the 7-segment display. 7-segment display is controlled by the BCD decoder, which is powered by 4 digital output pins of the Arduino using BCD codes. And the first digit is hardwired for a single digit to minimize the chip and pins used. So the problems that we encountered was that first the 7-segment display flickered. So as soon as you press the up and down button, it jumps to the next value, to random values. And the cause was that the inputs decoder needed a pull down resistor, because the pins will be floating and you'll be applying voltages from between the ground and source. Another one was the precision of the knobs. So all the way, as soon as you load a preset, it goes all the way to the right and all the way to the left. So the cause of this was that it's not constantly being read, and there's a delay between the rotating function. So what happens is it jumps the value and it could never find the saved value. And it'll keep spinning and looking for it. And the other one does not completely rotate back to the max value. It's because first the voltage regulator was supplying 5.06 volts, and the Arduino can only read a maximum of 5 volts. So when you turn the knob all the way to its max value and save it at that location, you're actually saving 5.06. And as soon as you load that, it will stop before that position because Arduino needs 5 volts.
Right, so another problem we had was a large amount of humming. We found out later that this was caused by improper grounding, because we thought that we had to keep all the high voltage and everything isolated, but in fact we actually had to keep it connected to earth ground. So when we connected it, then it stopped. Another thing we noticed was that when we hooked it up to an oscilloscope, there was a 53 kilohertz oscillation happening. I've found that it's likely due to a combination of electromagnetic and magnetic interference caused by compact fluorescent lights and other electronic devices. Usually when you turn a light off, it goes down, but it's still always somewhat there, so I'm just assuming it's from the environment. So just quickly show, this is our actual project. I'm going to go over an overview just so you know what you're looking at. Here is the actual power jack. It's got a built-in fuse block, and the wires come all the way here to the two switches. The first switch is the power switch, the second switch is a standby. So essentially what happens is when you power the switch up to the output transformer of the power amplifier. So you're going to see that in a moment. So, yeah, go ahead.
Say hi.
So you guys gotta be careful, don't touch anything here because a lot of it is exposed. So just give them all
30 seconds.
Yeah.
What's wrong,
So you gotta
Alex?
wait 30 seconds and you'll hear a click, which is gonna be the relay
What did you see?
connecting the high voltage.
All of this.
Alright, so that click was the relay allowing the high voltage power supply. The filaments at this point are warmed up somewhat. So you can hear there's a little bit of hum, but that's mainly due to the fact that there's such a high gain in the preamp, and it'll just pick up pretty much everything.
So first I want to demonstrate how you can save a preset. So as you can see, it'll go up to 10. And by pressing 2 buttons, it'll blink twice. And that means we're in the saving mode. So let's save like a pretty dirty sound right now. Yeah. And then if we're content with whatever settings we save, we press the set button, it'll blink twice, confirming that it has been saved. And see if we can recall that value by going to 10. It'll automatically rotate. Yep. And
I thought it was just gonna save.
And then this,
That's what I was saying.
this is how the sound would so, and we already made a preset before demo. And we also made a clean setting, which is in preset number 1. So this will automatically rotate to position we think we're doing. Yep. So here's the save, the clean setting. And we also set a setting between the clean and the dirty sound. So that's on preset number 2. Yep. So yeah. So it's kind of dirty. So I hope you guys.
Any questions?
So does anyone have any questions about our project?
It's a very good project.
It's pretty cool.
Yeah. Yes, you rocked.
When you use a Pinto, what's the difference between, I know the Pinto's got 5, they've got 2 extra screens in between. What's the advantage?
There's no advantage aside from the fact that you can't actually find triodes in that power range. It's been found that back in the day when they first invented these, that the triode had too much Miller capacitance between the electrodes. So what essentially happened was it would limit your gain at high frequencies, and there was no point in making triodes that large but have so little gain. So they figured that by adding extra electrodes, they could actually mitigate that, and ever since it's just been any power tubes are typically tetrodes or pentodes.
So you're putting those metal capacitors in series and then dropping it,
Exactly.
with feedback. And what did you find about matching the impedance for this? Did you have any experience with that, Raymond? I know that mostly it's your hardware stuff, but what did you notice about the sound when you were plugging your guitar in? Did you notice you're used to playing with your regular amplifier, right? Now you're playing with this? How does it compare?
So first, it was really loud because the thing wasn't grounded, the socket. It was louder than the regular amps we had. Now it can compare to the loudness of having it unplugged or plugged.
So how do you mean by impedances though? Because
Well, there's an input impedance. It's got an impedance on the pickup, not got an input impedance to the amplifier. So that impedance match or mismatch can determine a lot of the sound or distortion.
we found that because there's actually wires leading to that jack, those were basically acting like antennas, picking up all sorts of radio interference. So we actually had to take a meter to this guitar and measure the resistance of it. So essentially what we've done is we've added a 10K resistor. We measured the guitar at about 8K, so we figured 10K would be close enough. So we essentially added a 10K resistor to the actual socket. This type of socket disconnects one side of the contacts when you've plugged something in. So essentially when you leave it unplugged, there's the 10K resistor there kind of simulating the guitar and preventing the wires from picking up too much interference.
We better stop at that point.
Yeah.
We're already over time. Thanks very much.